U is always going to be that inside portion of that graph. So I'm going to go ahead and let U equal to 1 minus 4x squared. The derivative of U, that 1 goes away, and you're just left with negative 8x. But again, I want to write it using the du dx notation. And then I know that du is equal to negative 8x dx. And I know I'm doing all of these steps out step by step. And then finally, I know that dx is equal to du all over negative 8x. I'm writing all these steps out one by one because when we get to the trig functions and doing this with trig functions, it is helpful because they're not as natural to go ahead and fit all of those pieces in. So then I just go ahead, I know what dx is equal to. I take that and I plug it back up inside there, and I replace one minus 4x squared with u. So now I'm left with the integral of x over u to the third, and I'm replacing dx with du over negative 8x. Those x's cancel out, and I am left with, I'm also going to go ahead in one step right now. This is u to the third, which is in the denominator, so I'm going to go ahead and bring that up to the numerator. So now I pull out the negative 1 over 8, integral of u to the negative 3 du. Just be careful with negatives when you take the integral of this. This is u to the negative 3 plus 1. That just gives us a negative 2 plus my constant, or negative 1 over 16 times u to the negative 2 plus my constant. And now I'm going to go ahead and drop that back into the denominator. Oh, sorry, that should be a positive. I lost that negative sign there for a second. Forgot that one. So that definitely needs to be a positive. So now I'm going to plug back in u, and u is equal to 1 minus 4x squared. So all of this just becomes 1 over 16. The negative 2 I'm going to drop to the denominator, and now I'm left with 1 minus 4x squared quantity squared plus that constant. All right, so trig functions, same idea that we're doing here. Let inside the argument of whatever the trig function is be u. So when you do that, u is just equal to x to the fourth. Du is equal to 4x to, excuse me, du dx is equal to 4x to the third. So du is equal to 4x to the third dx, or dx is equal to du over 4x to the third. Then you're just taking all of this, putting it in for dx. I'm going to go ahead and make that the sign of u right now, and replace dx with du over 4x to the third. Then all of that is gone, and I just have the integral of the sine of u du. Now, the integral of the sine is just minus the cosine of u plus my constant. And then I just go back, and whatever u was equal to x to the fourth. So then all of that equals minus the cosine of x to the fourth plus the constant. So once you go ahead and identify what is u and what is dx, now like I said, I'm guessing that some of you can probably go straight to knowing that this is going to be 1/8 the cosine of u du. If you can go right to that step at this point in time, that's fine. Then I go ahead and take and integrate that, and I just get the fact that that 1/8 stays outside. The integral of the cosine of u is just the sine of u plus a constant, or it's just equal to 1/8 times the sine of 8x plus my constant. Now, just remember, always make sure you have your constant of integration in there, and your u just comes back up into whatever we initially set it equal to be before. Okay, hold on, let me record that. So the question was what sign we need to have. So if you have d dx of the sine of x, what I just wrote in green, what is the derivative of the sine of x? It's just the cosine of x, right? So therefore, when you go backwards, it would be positive. Last question that we had, if I had d dx of the cosine of x, what does that equal? That is equal to minus the sine of x. And all you're really doing with this is then multiplying both sides by a negative and making that the negative d dx of the cosine of x, which would turn that into the sine of x. When you're doing this, you really need to remember what's going on as far as what the derivatives of the trig functions were. Because if you don't recall what the derivative of either the secant is or the tangent is, you're going to have problems picking what u and du are. So the reason I know that I want to pick underneath here to be u is because I know that the tangent of x, I know the derivative of that is equal to the secant squared of x. That's the only reason why I want to pick that. If I don't know that, I don't know which one to pick for you. But you always pick that based upon what you have in those questions. So then this one, and this right here, I think, is the part where you have to be careful of, because you need to understand that inside here, one of these is going to be u, and one of those is the derivative of u. And if you don't know that portion of it, it's very difficult to decide what to do. But once I have this, it's pretty straightforward, because then du over dx is just equal to the secant squared of x. So that just tells me that du is equal to the secant squared of x dx, or dx is equal to du over the secant squared of x. And then I can just take all of this and replace all of this with du. So now I can go ahead and write the integral. So now I just have the integral of u to the 1/2 du. And again, that's just because this is a square root. I write that as a fractional power. So now I go ahead and just take the integral of that, which gives me that to be u to the 3/2 over 3/2. Oh, sorry, because you're just adding 1 to that and you divide by the same thing, plus my constant. Or 2/3 u to the 3/2 plus my constant. And then at this point in time, I just go ahead and plug back in what what u was. So all of this is just equal to 2/3 tangent of x to the 3/2 plus a constant. So, and again, the reason we pick this, the idea with the trig functions, is whenever you have this index is the power, I can go ahead and rewrite that as the sine of x over the cosine of x to the 3rd power dx. And that's why we wanted to go ahead and choose only this inside portion for u. Because when I take the derivative of just the cosine, that just gives me minus the sine of x. So du would equal minus the sine of x dx. Or I get that dx is equal to du over minus the sine of x. And this is where I think writing it all out helps, because this idea of those negative signs are really important that we don't get lost in those questions. So now when I go through and write this back out, I have, this is the integral of the sine of x. Everything inside here becomes u to the 3rd. dx gets replaced with du over minus the sine of x. So even though these cancel, what I end up having is I have to pull out that negative outside of that integral. So now this just becomes u to the negative 3rd du. All right, so let's just go ahead and finish that. You want to just write that as the negative stays out front. That's u to the negative 3 plus 1. Just be really careful with these negative signs. For whatever reason, whenever you're adding to a negative, it always seems to bother everyone. Plus my constant. Those negatives again will cancel out. And I'm just left with positive 1/2 u to the negative 2 plus my constant, and then I just replace that with 1/2 cosine of x to the negative 2 plus my constant, or there we go, let it equal to 1/2 cosine squared of x plus c.